Hello, welcome to this video for the level 3 integration paper for level 3 integration. Like the previous video, the marking schedules have not yet been released for these papers, so this video has a condition that there could be some mistakes in the workings, and if you do see any mistakes, please leave it down in the comments below. That would be greatly appreciated. However, hopefully that won't need it to be occurring. We'll just get straight into it. So like question 1a, just find the integral of pretty standard equation here. Pretty standard achieve level question. So in this case, for the 3x plus 2, we're just going to increase the power by 1 and divide by the new power. So this will be 3x squared on 2 plus 2x. For the 1 on 3x plus 2 term, we're going to look at the derivative of the bottom, which is 3. So we're going to have 1 on 3 on the outside times of line of 3x plus 2. And don't forget the constant of integration plus c. And this should just be a achieved level question there. Cool. So an object's velocity can be modeled by the equation v of t is secant squared t. V is the velocity of the object in kilometers per hour. And t is the time in hours from the start of timing. Initially, the object was 3 kilometers from a point P. So find the distance of the object from the point P after pi on 4 hours. So this is another very standard kinematics question. So remember we have a, v, and s. And to go from a, we need to integrate. And from v to s, we need to integrate as well. So simply we have s of t is equal to the integral of secant squared of t with respect to t. That is going to be equal to tangent of t plus of c. So now we want to find what is c. So c, we know that when t was 0, we know the distance was 3. So therefore 3 is equal to tan of 0 plus c. And we know that tan of 0 is 0. So tan of 0 is 0. So therefore c equals to 3. So therefore our s of t is tangent t plus 3. And now we just need to chug in the point on t equals to pi on 4. So we have s of t equals to tan of pi on 4 plus of 3. And that should give us an answer of 4. Let me just double check. Yeah, that should give us an answer of 4. So distance was 4, and this should be another achieved level question there. No surprises there. Cool. So let's look at question C. The graph below shows the function y is square root of x and 8y equals to x squared. We want to find the shaded area. So for these shaded area between two curves, just remember in simpler terms, you can just remember it's going to be the top curve minus the bottom curve, integrating between the points of intersection. So we have here and here. So clearly on this point here is x equals to 0. So we have x equals to 0 here. And we need to find the point of intersection here, which we don't quite know yet. However, we can find that point of intersection by setting y equals to y. So we have square root of x equals to x squared on 8. And therefore, we can say that 8 root x equals to x squared. So therefore, 64x equals to x power 4. So therefore, x cubed equals to 64. And therefore, x equals to 4. So this point here is actually x equals to 4. And we know that the curve on the top is square root of x. And the curve on the bottom is x squared on 8. So now we can find the integral between x equals to 0 and x equals to 4 between the two functions. So we have between 4 and 0 between the functions of square root of x minus x squared on 8. And we can just integrate this pretty easily. We can rewrite this one as we rewrite square root of x as x to the power of 1/2 minus x squared on 8. And now it's just a matter of increasing the power by 1 and then dividing by the new power. So in this case, we're going to have 2 on 3, x to the power of 3 on 2, minus x to the power of 3, so 3, and then 8 divided by 3, so 8 times 3 is 24 on the bottom, divided by x to the power of 3, plus c. Oh, in this case, we're not doing plus c, sorry. We're doing it between 2 points, so it's between 4 and 0. And this will give us 2 on 3 times of 4 to the power of 3 on 2 minus 4 cubed on 24 minus of, well, if you plug in 0 on the side, so just be 0, so we don't have to worry about that. So we have 4 to the power of 3 on 2 multiplied by 2 on 3. And we're going to take away 64 over 24. So that's going to give us an answer of 2.67 units squared. And that should be our final answer for this question. And this should just be a standard, merit level question for the correct area. Let's look at question D. So let's consider the differential equation dy on dx equals to y times of 2x minus 3x squared. So for this, this is a separable differential equation. So we can separate y on one side and all the x's on the other. So we can say that 1 on y, dy is equal to 2x minus 3x squared dx. And we can integrate with respect on both sides. So now we can say that line of y equals to the integral on the right hand side. So that's x squared minus x cubed plus of c, the constant of integration. And we know that when y equals to 1, x equals to 2. So we can use that to find the value of c. So line of 1 is equal to 2 squared is 4 minus 2 to the power of 3 is 8 plus of c. Line of 1 is 0. So 0 equals to negative 4 plus c. Therefore, c equals to 4. Great. So now we have our equation, which is line of y equals to x squared minus x cubed plus of 4. And now we can plug in the point x equals to 1 to find the value of y. So line of y is equal to 1 minus 1 plus of 4. So therefore, we can take we can exponentiate both sides. So y equals to e to the power of 4. And if you want a decimal for that one, that will be approximately 54.6. Alright, so that's going to be our the answer for this question. So it's about e to the power of 4, and this should be another merit level question for the correct answer there. Cool. So we can move on to question E. So the shaded region in the diagram below is bounded by 3 graphs, which is given below. We want to find the area of the shaded region. So for this question, it's pretty good, I think, to separate what you want. So in this case, we want this whole area here. And we can look and separate this into 3 distinct regions. So we have, we can have region 1, which is we can call this one region 1. We can call this part, we can call this one region 2. We can color code it actually. So we can say that that's region 1. We can call this region 2. And we can call this region here, region 3, so that will be separated right there. Alright, so now all we need to do is just find the area of these regions. So it's pretty important that we know what this point is, and we know what this point is. So in order to find this first green point along the top here, we need to set y equals to 3x equals to y squared equals 10 minus x. So simply we just set y equals to y, so it's just 3x equals to 10 minus x, square root in fact. So now if we square both sides, we'll have 9x squared equals to 10 minus x. And we have 9x squared plus of x minus 10 equals to 0. So now we just need to find the solutions for this quadratic. Hopefully we can factorize it relatively easily. Or we can just save ourselves the pain and just use our to find the roots manually. So we have negative 1 plus or minus b squared minus 4 times of a times of c divided by 18. So x equals to negative 1 plus or minus 1 over 18. What do we have on the inside? We have 4. Cool. And cool. We have 19. We have 19 on the top there. So we have 1 minus, so that's 361, and square root of 361 is 19. So we have 19 there. Hope I've done this right. It seems a little bit complicated. Oh no, not really. Okay, sorry about that. So we have x equals to negative 1 on 18 plus or minus 19 on 8. So we have x equals to negative 1 on 18 plus of 19 on 18. So that's x equals to 1. We also have x equals to negative 1 on 18 minus 19 on 18. That's going to be negative 20 over 18. However, we see here that clearly x is greater than 0, so we're just going to disregard that second solution there. Cool. Okay, so we're going to disregard that one. We're going to say x equals to 1. And if we just substitute back to double check, 10 minus 1 is 9. Yeah, now square root of 9 is 3. 3 times 1 is 3. So x equals to 1, that's our point there. And for this point, the second green point there, it's just setting y squared equals 10 minus x is 0. So clearly, that should be pretty trivial. That this point is x equals to 10. Okay, brilliant. Now we basically have all the information we need to find the area. So let's start with area 1. So area 1. So that will be the area integral of 0 to 1 of the curve 3x with respect to x. So this will be equal to 3x squared on 2, 1, 0. And that's going to be equal to 3 on 2 units squared. Cool. So that's our area 1. Let's look at our area number 2. So for our area number 2, we're going to be looking at the curve y squared equals 10 minus x, and that's going to be between the points of x equals to 1 to x equals to 10. So that's going to be from x equals to 10 to 1. And that is going to be the curve y squared equals 10 minus x. So we have square root of 10 minus x dx. We can rewrite this one as 10 minus x to the power of 1/2 dx. So for this question, we can just increase the power by 1. So if we increase the power by 1, we'll have 3 on 2. Divide by the new power, so that's 2 on 3. So we'll have 2 on 3, 10 minus x to the power of 3 on 2. And don't forget, because we have a 10 minus x in the inside, we have to take a negative in the outside, because the derivative of negative x is negative 1. And if we multiply by negative 1, we need to reset it to a positive. So we have a negative on the outside there. So we have negative 2 on 3 times of 10 minus x to the power of 3 on 2 between 10 and 1. So that's going to be equal to negative 2 on 3 multiplied by 10 minus 10, that's 0. So that's just going to be 0. Great. Oops. Sorry. So that's 0. And we're going to have minus of minus 2 on 3 multiplied by 10 minus 1 is 9. So 9 to the power of 3 on 2. Okay, what is that equal to? So we have 18. Okay, cool. All right, so that part is going to be equal to the 18 units squared. So that's going to be our area 2. And finally, we can compute the area 3. And that's simply going to be a negative of the integral from 0 to 10 of the curve negative sine of pi x minus 10. The reason it's negative is because it's below the x-axis, so we're going to be getting a negative integral. However, we want to consider the positive since we're looking at the area. So again, this should be pretty simple. We just have integral between 10 and 0 of negative sine of, what was it? Negative sine of pi x on 10. And in this case, all we need to do is remember to divide by the power, not power, in this case, divide by the derivative of the inside. So in this case, the derivative of pi x on 10 is pi on 10. So dividing by that, we'll get 10 on pi. And negative sign integrates to cosine. So we have cosine of pi x on 10. And we're going to be considering the points between 10 to 0. So now what we have here is we have 10 on pi cosine of 10 times pi on 10, so that's just pi, so cosine of pi, that's negative 1. So we have a negative of this one, and we also need to subtract off, what am I doing? So we need to subtract off negative, 10 on pi times cosine of 0, which is 1. So we have minus 20 on pi But remember, we said that this was the absolute value. So theoretically, we should be taking the absolute value here. So this is the absolute value, which is 20 on pi. And great, that's we have all the components needed to find our answer. So we have 20 on pi added to 18. And add that to 3 on 2. So our final area is approximately, if we just go somewhere else here, we can say our final area, so that's A1 plus A2 plus A3, that is approximately 25.866 units squared. Okay, that's our final answer. This should be an excellence level question. There's quite a lot of work regarding this question. There's 3 areas to calculate. And yeah, I'll just leave it there since I'm not too sure exactly how they'll be grading it. So I'll probably just stick with this being an excellence level question there. Brilliant. Let's have a look at question number 2. We want to find the integral of 4e to the power of 2x minus 1. So in this case, we just want to find the derivative of the power. So 2x minus 1 derivative is 2. So we want to divide by 2 and everything else stays the same. So we just have integral of 4e to x minus 1 with respect to x equals 2e to the power of 2x minus 1 plus c. That should be an achieved level question there. So question B, we want to solve the differential equation dy on dx equals to 4x plus 1 to the power of negative half. X is some non-negative number, given that when x equals to 6, y equals to 7.5. Alright, so it seems like a pretty straightforward just integration question. So we have y equals to the integral of 4x plus 1 negative 1 half dx. And in this case, we want to increase the power by 1, so it becomes a half. We want to divide by the new power, so that's going to be dividing by 1 half, so that's going to be multiplied by 2. But don't forget, we also need to multiply by the derivative of the power. We also need to not multiply, we need to divide by the derivative of the inside. So 4x plus 1 derivative is 4, so we have 2 on 4 times of 4x plus 1 to the power of 1 half plus of c. And that is just y equals to 1 half of 4x plus 1 to the power of 1 half plus c. We can use the initial points to find the value of c. So 7.5 equals to 1 half of x equals to 6, so that's 25 to the power of 1 half plus of c. In this case, we have 25 to the power of 1 half is 5. 5 divided by 2 is 2.5, so c is 5. So y is equal to 1 half of 4x plus 1 to the power of 1 half plus 5. And what else do we need to do? Okay, that's it. We solved the differential equation, so that's what we asked for. That should be another pretty straightforward achieved level question there. Okay. Okay, next question. Find the value of k given that the integral between k equals to 2 and x equals to k and x equals to 2 of 6x minus 3 divided by 2x minus 3. So for these types of questions, I really just like doing a long division. Okay, so very simplify the problem. So to get 6x, we need to multiply by 3. So we have 6x minus 9. Negative 3 minus of negative 9, that's going to be 6. So that becomes negative 3 plus 9, which is 6. So we have 3 as our divisor, and we have 6 as our remainder. So that's going to be derivative of k to 2 of 3 plus of 6 on 2x minus 3 dx. And we can just find the derivative, the integral. So now we have 3x plus of. So in this case, the derivative of 2x minus 3 is just 2. 6 divided by 2 is 3. So we have 3 line of 2x minus 3. And that's between points k and 2. And we know that this value equals to 3k. So it's just a substitution game now. So we have 3k plus 3 line of 2k minus 3 minus of 6 plus 3 line of 1. Okay, so that's just 0. That equals to 3k. That's going to cancel out there. And now we're going to have 6 equals to 3 line of 2k minus 3. And now dividing both sides by 3, we have 2 equals to line of 2k minus 3. We can exponentiate both sides, so e to the power of 2 equals to 2k minus 3. And now we can just substitute for k, so k equals to e squared plus 3 on 2. And that should be hopefully a merit level question there. Brilliant. Let's look at question D. We want to find the integral of cosine of 2x plus sine of 2x divided by cosine of 2x minus sine of 2x. So for these questions, there's a couple of things I like to do. So first thing I like to do is just like check whether the derivative of the bottom is something to do with the numerator. So let's just check that. So let's check derivative d dx of cosine of 2x minus sine x. So that's going to give us negative 2 sine of 2x minus 2 cosine of 2x. And would you look at that? This is very similar to what we have on the top. So on the top, we have cosine 2x plus sine of 2x, which is exactly the same as saying of this expression here, multiplied by exactly negative 1/2. So brilliant. So that's basically, we already have our answer here, basically, because if we multiply negative 1/2 by this derivative here, then we will get back what we have on the numerator. So in fact, the integral integral is in fact just equal to negative 1/2 line of cosine of 2x minus sine of 2x plus c. Yeah, that's really it to it, because if you think about it, when you differentiate this curve here, we're going to multiply by the derivative of the inside of the line. So remember, that's what the expression we got here. And remember, we just said that if we multiply by negative 1/2, which we put on the outside here, we will get back to what we have on the numerator. So therefore, this is exactly the correct answer is what we have here. Brilliant. Okay, that's probably another merit level question. Okay, so let's have a look at question E. The cake factory has a container of liquid chocolate that's used to manufacture chocolate cakes. The liquid chocolate is pumped out of the container so that the rate of change of the volume of liquid chocolate remaining in the container is proportional to the square of the volume of liquid chocolate remaining. So that's pretty important, proportional to the square of the volume. And after 1 hour of use on a particular day, the volume of chocolate remaining is p liters, where p is a positive constant. So that's 1 hour, we have p liters. After another 1 hour, we only have 4 and 5 p liters of chocolate remaining. So what we want to do is write a differential equation that models the situation and solve to calculate how much liquid chocolate was in the container at the start of the day, giving your answer in terms of p. Okay, brilliant. So there's a lot of stuff going on here. There's like p, there's like 1 hour, 2 hours. But the thing we want to start off here is just like we're given the information that the rate of change of the volume is proportional to the square of the volume. So let's just get that down first, okay? So the rate of change of the volume, dv on dt, is proportional to some k, we don't really care what it is, some constant times of the volume squared. And now this is just another separable differential equation, okay? So now we have 1 on v squared. And we can integrate this with respect to v. And we can integrate the right-hand side with respect to t. And the integral of 1 on v squared, okay? So that's, remember, that's going to be the same thing as integral of v to the power of negative 2. So we're going to increase the power by 1, so that's negative 1, divided by the new power. So 1 divided by negative 1 is negative 1. So now what we have is just negative 1 on v. That equals to kt plus c. Okay, brilliant. Okay, we already have some good start here. So now we want to find what's k and what's c. So we have 1 hour on a particular day. We have p liters. Cool. So when t equals to 1, v equals to some p. We don't really care what that is. So just v equals to p. So we have negative 1 on p equals to some k times t, so that's k plus c. So therefore, we can say that c is equal to negative 1 on p minus k. Cool. So now we have negative 1 on v, that equals to kt minus 1 on p minus of k. Cool, and now we're going to say after another 1 hour, so that's t equals to 2, there's only 4 on 5 p liters of chocolate remaining. Cool. So now we just have negative 1 on 4 on 5p. That is equal to 2k minus 1 on p minus of k. So maybe just simplify this a little bit here. So we have negative 1 on 4 on 5. Okay, so that's negative 1.25 on on p, that equals to 2k minus 1 on p minus k. Or well, we can simplify that just to be k, so we can just have k minus 1 on p. Cool, and now we can add 1 on p on both sides. We have negative 1.25 on p, adding on to 1 on p, that equals to k. So therefore, what is k? K is equal to negative 0.25 on p. Oh, not 4, sorry, on p. Brilliant, so now we have a lot of information. So now we have negative 1 on v equals to negative 0.25 on p. That's going to be the k, so that times of t minus 1 on p, and minus, remember, k is this value here, so that's plus 0.25 on p. Brilliant. So now we just want to find how much liquid was in the container at the start of the day, so that's when t equals to 0. So 1 on v, negative 0.25 divided by p times of 0 minus 1 on p plus 0.25 divided by p. And what am I doing? So in this case, that's 0. Get rid of that. Negative 1 on v equals 2. Negative 1 plus 0.25, that's 0.75 on p. So now we can say that negative p equals to negative 0.75 v. And now we can divide both sides by 0.75. Hopefully I didn't make any silly mistakes there. Okay. So we have 1 divided by 0.75. Okay, so now we have v equals to 4 on 3 p. That's 1.333p. All right, that's our final answer for this question. So that's 4 on 3p. That should be an excellent level question there. Cool. So that wasn't too bad. So let's look at question number 3. A garden designer wants to find an approximation of the area of a section of the garden shaded below. There's some measurements. Using these measurements and Simpson's rule, I want to find an approximation of the area on the garden of the section. So for this one, it's basically you can just like memorize, or you can refer to the formula sheet for Simpson's rule. So just estimating the area using the Simpson's rule. So in this case, for each of these trapeziums, we can look at the height, which is 3 meters. So h equals to 3. So h equals to 3, and now we have to consider each of these respective heights. So we can consider y0, y1, y2, y3, and y4. And if you just, basically it's just all about just basically chugging it into the equation. So we're saying that the approximation, so we can say approximation is 1 on 3 times h, which is 3, multiplied by, we're going to say y0 plus the last one, so that's 10 plus 14, plus 4 times all the odd indexes, so that's 4 times of 13 plus 15, plus 2 times all the even indexes, so plus 2 times of 16. So that's 1 on the outside. We have 24. I'm just going to use a calculator. I cannot be bothered doing mental math. Mental math is not fun. Okay, so we have 13 plus 15. What is that? 13 plus 15 is 28 times of the 4, plus of 10 plus of 14, plus of 32. All right, so that's about 168. Okay, so that's about, our estimation is saying that this is going to be approximately 168 meters squared. Cool. So we can move on to the next one. So we can say find integral of square root of x minus 3 on square root of x. So for this question, we can probably just simplify by dividing through by square root of x. So we have integral of 1 minus 3 on square root of x dx. And we can rewrite this one as integral of 1 minus 3x to the power of negative 1/2 dx. And now it's just a matter of integrating. Remember, increase the power by 1, divide by the new power. So this is just x minus of negative 1/2. So I have 1/2 divided by new power. So that's 6. So that's 6 root of x. Plus c. All right, never achieved level question there. Okay. Let's look at question C. The graph below shows the function y equals to 5 sine of 3x sine of x. We want to find the shaded area. So for this question, it's just a matter of just integrating between 0 and pi on 3. So we have pi on 3, 0, of 5 sine of x sine of 3x dx. So for these types of questions, because you can't really, I mean you can, but you can't probably integrate, but in this case you want to probably simplify this equation into something that's really easily able to integrate first. So probably what we're trying to be looking at here is probably trying to convert sine of x multiplied by sine of 2x. That's equal to some sine of x plus cosine of x without, like, basically basically products to sums, okay? So in this case, we're going to be using the product to sums. We have two sines. So remember the rule, basically you can just use the formula sheet for this one. So 2 sine of a sine of b, that equals to cosine of a minus b minus cosine of a plus b. Okay, cool. So now we have 5 on 2. So 5 on 2, we need to say, so we have cosine of a minus b, so a minus b, so that's negative 2x. And we have minus of cosine of a plus b, so a plus b, that's cosine of 4x. And that's going to be our new integral. And now this is pretty simple to integrate. Okay, it's pretty, sorry, that's to be the whole thing. Okay, that's pretty simple to integrate. Okay, we can probably just, what we need to do here is just integrate the cosine. So cos goes to positive sine, and we need to divide by the derivatives of the insides. So remember, we have negative 5 on 4 times of sine of negative 2x. And we also have negative 5 on 2, 5 on 8. Negative 5 on 8. Let's see if, hopefully I didn't make any mistakes here. Negative 5 on 8 sine of 4x. And that's between pi on 3 and 0. So that's going to be negative 5 on 4 sine of negative 2 pi on 3 minus 5 on 8 sine of 4 pi on 3 minus of negative 5 on 4 sine of 0 minus 5 on 8 sine of 0. Oh, well, that's just 0, so we just can get rid of that. So that's going to be equal to, so we have sine of negative 2 pi on 3, so sine of negative 2 pi on 3. Okay, so we have negative 5 on 4 times negative root 3 on 2 minus 5 on 8, so sine of 4 pi over 3, so sine of 4 pi on 3. That's going to be negative 3, 2. So we have negative 5 on 8, so positive 5 on 8 in this case, root 3, plus 5 root 3 over 16. 5 root 3 over 16, and 5 root 3 over 6. Yeah, okay, cool. So if we can just write that one down as in the decimal form, that's also fine. So we can write that as plus of 5 root 3 divided root 3 divided by 16. Alright, so that's about hopefully that's right. So that's about 1.624. Okay, brilliant. So question D, the object's acceleration can be modeled by the equation a equals to e on 2t divided by 4e to the power of 2t minus 3. So, okay, so t is some non-negative number, a is the acceleration, t is the time. And yeah, we want to find the velocity when t equals to 4. So we want to integrate the acceleration to find the velocity. So v of t is equal to the integral of e to the power of 2t divided by 4e to the power of 2t minus 3 dt. Okay, so for this question, again, we can look at the derivative of the denominator here. So d on dt of 4e to the power of 2t minus 3. That is equal to 8e to the power of 2t. So in order to get from 8e to the power of 2t to get to e to the power of 2t, we just need to divide by 8. So realistically, all we have here is just 1 on 8 line of 4e to the power of 2t minus 3. Of course, you can also use like the u substitutions. You can say u equals to 4e to the power of 2t minus 3, so du on dt equals to 8e on 2t. So therefore, you'll get integral of e to the power of 2t divided by in this case we have u, and in order to get dt we have dt equals to du on 8e to t. So that's goodbye. So then you'll see again it's very much the same. So we have 1 on 8 line of u plus c. So this is just the same as 1 on 8 line of 4e to the power of 2t minus 3 plus c. Okay, so that's our v of t. And to find the value of c, we plug in our initial condition. So t equals to 0, v equals to 5. So 5 equals to 1 on 8 line of 4 minus 3, that's 0, plus c, so that's 0, bye-bye. So c equals to 5, cool. So now we have our v of t equation. So v of t equals to 1 on 8 line of 4e to the power of 2t minus 3 plus of 5. And we need to find the velocity when t equals to 4. So v on t equals to 1 on 8 line of 4e to the power of 8 minus 3 plus 5. Okay. Alright, so that should be approximately 6.173 meters per second. Okay, let's look at the final question. Let's look at question E. Consider the differential equation 1 minus x squared times 1 plus y dy on dx equals, plus of 1 minus x times 1 minus y squared equals 0. So for this question, what we want to do is we want to probably make this into a separable differential equation. So that's probably what we're trying to do here. So we have 1 minus x squared, 1 plus of y, dy on dx equals to negative of 1 minus x times 1 minus y squared. And now we can separate. So we have all the y's on one side and all the x's on one side. So we have 1 plus y on 1 minus y squared, derivative with respect to y. And that's going to be equal to negative of 1 minus x divided by 1 minus x squared. 1 minus x squared. Okay, cool. And that's with respect to x. Okay, so let's rewrite this one as 1 plus y divided by 1 plus y and 1 minus y. So that's going to give us the same as the denominator, so that's going to cancel each other out. So goodbye to that. And we want to, on the right hand side, we can probably do something similar. So we have negative 1 minus x. On the bottom, we can rewrite it as 1 minus x times of 1 plus of x dx. Okay, so that's goodbye to that. So now we have integral of 1 minus y d with respect to y. That equals to the derivative of negative 1 or 1 plus of x with respect to x. So this is negative line of 1 minus y. Remember, it's negative line because derivative of negative y is negative 1, so we need to have the negative 1 on the outside. And that's going to be equal to negative of line of 1 plus of x plus of c. Cool. Okay, nice. So now we have y equals to 0, x equals to 2. We can use that to find the value of c. So we have negative line of 1 equals to negative line of 2. So 1 plus 2 is 3 plus of c. Line of 1 is 0, so we have line of 3. So c equals to line of 3. So therefore negative line of 1 minus y equals to negative line of 1 plus x plus line of 3. And we want to find the values of y when x equals to 6. Okay, no problem. So we have negative line of 1 minus y equals to negative line of, so x equals to 6, was it? Okay, 6, so that's line of 7 plus line of 3. And we can say that, what we're going to do here, we can multiply both sides by a negative 1. So we have line of 1 minus y equals to line of 7 minus line of 3. And we can basically just find we can basically just exponentiate both sides. So 1 minus y equals to e to the power of the line of 7 minus line of 3. And remember that's equal to e to the power of the line of 7 on 3. Line and e will cancel each other out. So we have 1 minus y equals to 7 on 3. Cool. And now we just need to rearrange this equation. So we can say that y equals to 1 minus 7 on 3. Brilliant. So that's going to give us y is equal to negative 4 on 3. And hopefully that's the correct answer. And that should be obviously it should be an excellent level question here. Let me just double check that there are no silly mistakes. Minus line of 3. And e to the power of both sides. 7 on 3. 1 minus y. Yeah, that looks... I don't see any mistakes here, so that looks perfectly fine to me. Perfect. Okay, so we have y equals to negative 4 on 3, and that concludes this paper. Hope you enjoyed the video, and like I said, if you've seen any mistakes in the video, please point it out in the comments below. But I hope to see you all in any future videos, and thank you.